Hi, my name is Joel Calhoun, and I'm a part of the Pediatric Pulmonary Emission device senior design team. And I'm here with JohnDavidLancaster, Zach Uttley, and HadimMbye. The purpose of our team is to create a device that works with doctors to give a device to children under the age of 12 to have a device that will train them on how to take a spirometry test effectively. This device will go home, and the goal is to have it operate at 3.3 volts and allow the user to interface with it through a singular tactile switch, a few LEDs, and an audio amplification circuit. Now I'm going to hand it over to John to talk more about the device specifications.
Thank you, Joel. If you look at the system overview section of our poster, you can see our board and the wire diagram of the device. It's important to note, like Joel said, this is just a device that is used for the participants to test and train so that they are able to accurately perform when they get into the doctor's office. And so our electronic device fits within the entire housing in the upper portion of the device, which you can see in the wiring diagram. This device senses whether or not a user has blown continuously 6 seconds through the middle of the tube with a mouthpiece that is stopping from inhalation so that the breath is constant. LEDs and speakers are used to interface with the user. And with that, I'll hand it over to Zach to talk a little bit more about the circuit schematic.
Thanks, John. So looking at the circuit schematic, our major inputs are going to be our power switch as well as our barometry circuit. The power switch, like John said, is the main way the user is going to interface with our device, and the barometer is the main way that our device is going to detect whether or not the user is actually blowing through the device. Our main feedback is going to be LED as well as our speaker, which is going to signal to the user whether or not they successfully completed this barometry test or whether they need to take it again because they did not successfully take the test. Moving over to our software integration section, you can see the flowchart detailing the procedure of our test. Our major software goals for this device were 1, allowing the user to interface with the device through a single tactile switch, and 2, providing audio and visual feedback to whoever is taking the test. And with that, I'll hand it over to Hadim to talk about the rest.
Thank you, guys. As you can see, this device was just is just going to be used for training instead of the actual spirometry test. So budget was a big concern in this project. So we intend to sell this price at the intended price of $70, so that it's going to be accessible to the general public. So that's why we have our parts to be so cheap that we can make a very affordable device. So to summarize and conclude at this point, we were able to communicate with our board, and we have the LEDs lit up, and we have audio on the board, and also our board fits perfectly into the casing, which we tested and was accessible to the participant for the LEDs and the power switch button. So we did. We are at a good point right now, and that's where we are right now. Thank you.
Thank you.